Greetings and welcome, internet friends. Mr. Waddy here, just hanging out, social distancing, teaching math from home. I've been doing a little bit all right myself, learning new things, investigating new hobbies. Using this time as best as I can, right? Leveraging the opportunities I've got. So no need to be down on all things that we're missing out, such as seeing each other face to face. Always learn something new every day. And today, we're going to be learning about nth roots. Nth roots, nth roots, nth roots, nth roots. You can extend the concept of a square root, right, which we've done square roots before. We've talked about the fact that the index of a square root is an invisible 2. You can extend those to other types of roots, and we've already seen this a little bit as well. We've talked about, for instance, a cubed root. So a cube root, and I usually probably always say cubed in my head, don't I? Probably. A cubed root is a cubed root of 8, for instance, is 2. The cubed root of 8 is 2. There's only one. Because 2 cubed is 8. So a cubed root is asking the question, what number multiplied by itself, right, a total of 3 times, there are 3 factors, right, 2 times 2 times 2, will give me 8. That's the question that's being asked when someone asks for a cube root. What number multiplied by itself a total of 3 times will give me the number on the inside? And so, if b to the n is equal to a, then b is an nth root of a. And so I can write it like this. So we'll have 4th roots, we'll have 5th roots, all sorts of wonderful things. And this little number does need to be written, whereas for square roots, you could have it invisible or with a 2. These cases, you do have to write the index, because otherwise I'll think I was talking about a square root, and those little numbers are called the index, or the indices, if I pluralize it. You can also write it in nth root as a power of a, and this is what's quite unusual, is that a square root of a number is the same as that number being raised to the 1/2 power. And so a second root will give me a 1/2 power. A cubed root of a number, and I guess, yeah, that's kind of being displayed down here, is the same as a to the 1/3 power, right? And so if it's a cubed root, 1/3 power, same idea as presented there. And so it turns out, in general, the nth root of a is equal to a to the 1/n. Excellent. All right, let's get to work. Now, all right, before we get to work, here we go. We got some more facts. Now, if I take a square root of a number, square root of 4, technically there are 2 square roots of 4. There's a plus and a minus. And so it's plus or minus 2. But if I take an odd root of a number, there's only 1 and 1. Now what's interesting is for negatives, there can be a root if it's odd. Because, right, for instance, if I asked the, quiet guys, the cubed root of -8 is -2, because -2 times -2 times -2 is equal to -8. All right, and so because these two negatives would pair up and become positives, but one minus sign would be left over. Also notice the cubed root of -8 could not be positive 2, because 2 times 2 times 2 will never equal -8. And so that's why there's only 1. If I take the nth root of 0, it's going to be 0. if I take the nth root of a positive number, it's going to be positive. Now, in the case of square roots or even roots, it's going to be quite tricky. Now, we've talked about, oh yeah, this is great. We've already talked about imaginary numbers. And so, if I take an even root of a negative number, there are no real roots. But we do know that there are imaginary roots. And it turns out there will be 2 of them. That'll come into play a little bit later as well. If I take an even root of 0, like a 4th root or a 6th root, it's just 0. Actually, you'll notice that this 0 thing is the same whether my index is even or odd. It's going to be the same thing either way. And then, this is what we're typically used to, is that an even root of a positive number has 2 real answers. And so this 2 and this 2 imaginary is the same thing. Okay, so you know what? It's probably going to be beneficial for a little while for you to continue to look back at this little chart when you're doing these problems. So that way, you'll keep on track with all that. So let's see. Here we go. Find the nth root of a. And so let's see. So the cubed root of negative 216. Now, let me just look at my properties first. So the index is odd and the inside is negative. So I'm talking about this scenario. I'm expecting 1 real answer. And in fact, I'm expecting the answer to be negative. Now, as far as the cubed root of 16, I believe that's just plain old 6, isn't it? I think so. Oh dear, what did I do? Oh my goodness, my kids break this calculator? I hope not. Oh dear, my calculator's set in crazy mode. Memory cleared. Oh wow. Should check that before I go live, I suppose. Alright, yeah. Anyways, the cubed root of 216 is 6, so the cubed root of negative 216 is negative 6. Over here, this would be the same as the 4th root of 81. Now, 4 is even, and 81 is positive, so I'm expecting 2 real roots. And so I'm expecting a plus or minus. And now 81, you might be thinking like, oh, that's going to be 9, because yes, you're correct. 9 squared is 81. However, I'll also point out that 3 to the 4th is 81. And so if 3 to the 4th is 81, then the 4th root of 81 must be plus or minus 3. And now as far as it having 2 real roots, there's kind of some weird behavior that's slightly different. If I ask you to evaluate, this is weird because they didn't actually specify right here. They didn't write the problem for me. Let's see, I'm trying to not make this crazy. Come on, Brian. Come on, we've got this, Mr. Waddy. Come on, Waddy Math. If I asked you to find the square root of 2, or sorry, if I asked you to find the square root of 4, it would just be 2. If I ask for plus or minus the square root of 4, that'll be plus or minus 2. And so if it didn't indicate the plus or minus at the beginning, which notice for these problems, they didn't actually write it out for us. But if they didn't write the plus or minus at the beginning, they're only asking for the positive even root. And I realize I'm adding some complexity here. And later on, if I asked you to solve the equation x squared equals 4, in the process of solving, if I root both sides, plus or minus is going to need to show up when solving. And so when solving, you do get plus or minus 2. You get 2 answers that way. You get 2 answers this way, because they didn't give it to me in this format. But I've got to be careful. There were 2 answers that they were. So yeah, this is just square root of negative 49. Wait a minute. Even index, negative number. No real is what's going on there. But I would point out, actually, we know that I could have broken out the square root of -1 and the square root of 49. Chances are, now, because I'm blending together a couple different units from different books, 3 different units, in fact, in this case, they probably would have accepted just saying no real answer. But the square root of -1 is I, and the square root of 49 is 7. And so there's technically, plus or minus. Yeah. Plus or minus 7i would happen there. All right, so here's a new thing for us. Another way of dealing with roots is to rewrite them as rational or fractional. If you want to think about it that way. Let's see. I'm going to write it. Boom. Fractional exponents. Okay, and then just remembering that the denominator of the exponent is the same as the index. All right, the denominator is the same as the index of the radical. So, here we go. Oh, I think I have the property show up later. That's fine. So 16 to the 3/2 power. There's a few different ways I could write this. Now the 2 is going to be my index. And so I could rewrite this as a square root, and this one, the 5, could be rewritten as a 5th root. And so I could rewrite this as the square root of 16 all cubed. Okay? So the 2, the denominator of the exponent, becomes the index of the radical. Square root of 16 I can evaluate, that's just 4. And then I would cube the 4 and get 4 cubed is 64. All right, so there's a way that I could evaluate that. Technically, I also could use a property of exponents. 16 to the 3/2 power, I could have also written it as 16 to the 1/2 all to the 3. 16 to the 1/2 power does not mean divide 16 in half. Okay, just so you're aware. I'm not multiplying by a half. I'm raising 16 to the 1/2 power, which is the same as square rooting. Those two things are identical. And so the square root of 16, you'll eventually get used to just realizing, oh, that means square root. And you'll be able to be rapido with that. 4 cubed. Over here, the denominator becomes the index. And this -3 would still be in the exponent. The 5th root of 32, now I happen to know this. Actually, if you're into computers, you might know this, because 32 is a power of 2. It's 2 to the 5th. And so the 5th root of 32 is 2. And, oh man, this is sneaky. They're throwing a property of exponents at us right now with a negative exponent. Which actually, I happened to write some of these down earlier. Back from A1 6.1, properties of exponents, if you want to look these up. Negative exponents, you can move the exponent downstairs and make it positive. Was the way that we dealt with negative exponents. And so, for this problem, I'm going to do just that. I'm going to rewrite this as 1 over 2 to the positive third. And that, let's see, I guess now I'm trying to keep my lines of work here proper. 1 over 2 to the positive third is 1 over 8. And so that would be the final answer there. So yeah, a little bit tricky, but this is the idea. The denominator of an exponent becomes the index of the radical. So let's see. Let me just speed run some of these. So this is the same as the 4th root of 81 all cubed. 4th root of 81 is 3. 3 cubed is 27. This one's interesting. So this would be the 8th root of 1 to the 7th. The 8th root of 1 is 1. Why? Because 1 times 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 1 is 8. And then 1 to the 7th power is 1 times 1, right? 7 of them, and that's also 1. Tell you what, I'll do this one real quick. So this is the same as the square root of 9 to the negative 1 power. So the 2 became the index. Tell you what, if you want to write those 2's there, you can. Square root of 9 is 3. And 3 to the negative 1st power, I'd move downstairs, and that would equal 1 over 3 to the positive 1st power. So that's 1/3. Good stuff, good stuff. All right, here we go. Now, what about con sus calculadora? So if I was using a calculator, and I'd already reached off screen and used a calculator when I was calculating the cubed root of 216 but a moment ago. But it's going to be helpful for you to know how to do this as well. And the way you're going to need to do this is with an nth root button, okay? And so you'll notice you already had, for calculating square roots, you already had access to the square root feature by hitting second and then the x squared button. And very similar to that, to calculate an nth root, it's going to include hitting second and this button. And there's an, I guess they call it an xth root in that case. But the order that I do it matters. And so what I would do is I would hit the index, in the case of these calculators, the index, then I'd access the nth root, and then I would type my radicand. Tell you what, I haven't picked colors of these. Right. And so then I would type in kind of whatever numbers I was trying to access there. So, all right, let's do this. So 9 to the 1/5 power is the same as the 5th root of 9. There is no 5th root of 9, and so this is why this is an approximation. Or there is a 5th root of 9. It's just going to be a decimal. It's not going to be a pretty number for us. And so when calculating the 5th root of 9, I've got to, let's see. Well, I'm going to do it on this calculator over here. So I'm going to type 5, and then I'll hit second, and then the xth root button, and then 9, and I'm getting 1.55184, etc. And so I'm going to, from this point, I've got to use approximately, not exactly equal, and I'm rounding to 2 decimal places. And so this is 1.55. It's not 56 because the following decimal was a 1, is less than 5, and so I don't round up. And so 1.55 is the answer. Let's see. It is possible, by the way, that you actually could enter it in the calculator in that form. I also could have entered it as 9 caret, and it probably would need parentheses 1 divided by 5. But that theoretically should work. Let me verify it on this calculator. 1 divided by 5, and I get the same answer. And in fact, I'm going to open up Desmos for you right here. So if the easiest way to enter something in Desmos, by the way, let's see, what was that? The next one is 12 to the 3/8 power. If I actually just do 12 and then I hit Shift 6 to access the caret, there's also like in the little calculator menu down here, you could technically hit A to the B, right? Whatever. And as long as I'm in that exponent, I could type 3/8 and it would calculate it. It is possible, if you are a fan of the symbol, to have an nth root show up rather than using the rational version of it. It is possible to access that, but it requires like, okay, let me show you all the steps that it requires. You'd have to click on this calculator tool. You'd then have to go over to functions, right? Regular square roots there, but where's the other one? You'd have to click on functions, and then I think it starts with trig functions here. You'd click on miscellaneous functions, and there's the nth root button hiding right there. And so it is possible I could hit the 8th root of 12, and then if I raise that to the 3rd power, I would get the same answer. That's a lot of work. It's way easier entering it, I think, just using the caret button on this calculator, just plain old caret without hitting second, and then just raise it to the parentheses fraction that you have right there. But tell you what, let's see, 2.539. Oh, I'm going to have to round that up to 2.54 once rounded, right? And so, by the way, you also could have written this as the 8th root of 12 all to the 3rd power if you wanted. Let's see, a bunch of ways you could do this. We could do 4th root of 7 and then cube it. We could, you gotta stay quiet, bud. We also could rewrite this as 7 to the 3/4 power. That's pretty good too. And so I'm hitting it on my little calculator. Actually, is it going to be mad at me if I don't put parentheses around the 3/4? Let's see. Yeah, it does need the parentheses. So yeah, if you're using a TI calculator, I'm sure your scientific calculators on your smartphones have similar features. But yeah, you've got to put parentheses around that if you're doing it this way, just so you're aware, because they're doing 7 to the 3rd and then taking that answer and dividing by 4. Okay, let's keep cruising, Mr. Waddy. Here we go. And so what did I get my answer? Here we are, 4.30. And these are approximations because these are irrational numbers. These are infinitely long, non-repeating decimals that I'm getting as answers here. And so it's possible to do all of these things. Yep, it is possible to have an odd root of a negative, and yeah, so this is the same as the 5th root of 6 all squared, right? All sorts of different ways to deal with these as you enter them in a calculator. Let's see, last type of problem. Solving equations using nth roots. And we're going to actually revisit this a little bit later as well. But here you can at least get a rundown course on how to do it. Now remember, when solving equations, we follow the process SADMAP rather than PEMDAS. I do PEMDAS in reverse. I'm undoing the things that are happening to the variable. And in this case, 2 things are happening to x. X is being raised to the 5th power and multiplied by 4. And so 2 events are happening: exponentiation and multiplication. Now, according to PEMDAS, the exponent is happening first and then the multiplication. But in solving, I'm going to deal with the multiplication and then the exponent in this case. So to solve this equation, I'm first going to divide both sides by 4. And so I'll have x to the 5th equals, what do you know? It's 32. 32. And now, the inverse operation of raising something to the 5th power is taking a 5th root, right? So just like the inverse operation of multiplying by 4 was dividing by 4, now the inverse operation is 5th rooting. And now question, is this going to have 2 answers or 1? Well, if it was even, I would immediately have to write plus or minus. But because 5, the index is odd, I don't. And so the answer is plain old 2. X equals 2. And so it is possible to solve equations that have higher degree exponents in them. And I do it by taking nth roots, both sides. All right, for this one here, and I'm not going to do the other examples because this video is running a little long. X minus 3, and my tablet's acting up, all to the 4th power equals 21. Now, notice I can't add 3 to both sides. Why not? Well, I'm allowed to. It's just not helpful. The 3 is locked inside this parentheses. And so the first thing I'm going to need to do here is get rid of this exponent. The way I'll do that is with a fourth root. And now question, oh, are there one or two answers? Well, n is even, and I'm taking it of a positive number, and so there are two real roots, and this number does not have a fourth root. It's not a perfect fourth. So I'm going to get a decimal approximation here in a second. But the point is there are two answers, and so plus or minus the fourth root, because this was even. And so I will have x minus 3 is left over. And the reason is because this canceled out with that, just like the fifth root canceled out with the fifth power, equals plus or minus the fourth root of 21. And now I could add 3 to both sides. And I can't combine those. Those are definitely not like expressions. They're like radicals. And so I get x is exactly equal to, we'll tell you what, I'll write it 3 plus or minus the fourth root of 21. Now, actually, let me check. Do they want, oh dear, I didn't give myself the answer key. This is an exact answer, by the way. But let's get a decimal approximation. And you can fast forward as I'm typing buttons in the calculator. Fourth root of 21, I'm getting 2.14. So 3 plus, I'm getting x is approximately 5.14, or 3 minus that, and I'm getting 0.86 when rounded. And so I have a feeling that's probably what the book will allow. But now, since many of you are doing your homework on big ideas math, just be aware it might be finicky in the way that you enter it. If it asks for round 2, make sure you round to 2 and don't just like cut off your decimal at 2 places. So round up when you need to. Right. If you enter it this way, I don't even know if they would end up appreciating that or not. It might be picky, and so you might end up having to quote-unquote burn some of your attempts per problem in order to get those correct. All right, well, thanks for watching, Internet friends. Y'all have a good day. Adios.